Welcome to Hamer Reviews. My name is Christopher Hamer, and today we're talking about solar energy production in the home. Now, if you're subscribed to the channel, you may well have already seen the Tesla PowerWall 2 review that I've recorded. Link to that above in case you haven't. But that system was installed at my parents' house, which I helped a tiny bit with, but not a huge amount. And I have finally decided to get my own solar power system installed at my own home. And it's a bit of a minefield, depending on what installer you use and what information you read. It's quite hard to see the wood for the trees. So I've decided to create a series of videos, of which this is the first. And I'm going to be talking to you about the entire process of picking out a system, working alongside your installer. Then the next video is going to be talking about the installation process of the solar system I'm having done at the moment. Already partially done, but not quite. And then we're going to be looking at some of the specific items in detail, plus long-term videos about the performance of the system, because I'm doing something a bit left field. I have solar panels on a north-facing roof. So that's going to be interesting here in the UK. Anyhow, let's jump into it. So let's say you're thinking of buying your own solar system. What do you need to know? Well, there's probably two ways of going about it. The first is that you can get a couple of quotes from local installers, choose the one that's either cheapest, has the most production, or looks the most interesting, or the company that has the best reviews, and go with it, and that's pretty much it. The thing is, I just don't like being that disconnected from a process. So this video is to help people who are in the position I was in, of I want to do this, but I don't necessarily want to trust one person's or a series of companies' ideas on what I should be doing. Don't get me wrong, they're supposed to be experts. However, in my opinion, there's nothing wrong with doing your own research and bringing your own ideas to the table. I'm going to be talking about some UK-specific stuff with regards to regulation, but the rest of this is completely relevant to you regardless of where you are in the world. So if you want to tune out for that bit, you can always use the chapters below, that's fine. And if you want to listen in, of course, that's fine too. And if you're in the UK, I'd suggest you do. So the first thing you need to really know is that any solar power system has two main components. The first, obviously, the solar panels, and the second is the inverter. Now, the solar panels create DC, direct current power, through the sun, and then the inverter takes that direct current power and turns it into alternating AC current power, which is what your home uses. So those are the two main components. Now, there are other parts that you can add to this. For one, there are items called optimizers. These are used in addition. There's one for each panel if you use them. And they allow you to, well, as the name suggests, optimize the current and output of each panel individually. Why is that important? Well, when you have solar panels connected together, you'll need to have a series of them connected to your inverter. And that literally means in a string. So they're each connected to each other, and then the last one connects up to your inverter. Now, on each string, if you do not use optimizers, if one were to fail, the whole string wouldn't produce any power. Equally, if one panel were to degrade or be in the shade, and therefore not producing as much power as the others are, you would be limited to the lowest amount of power being produced on that string by a panel. So for instance, you have 10 panels, each of which are, let's say, 300 watt panels, but one panel is stuck in the shade and is producing 80 watts. It would limit you to 800 watts in total, because that one panel not producing enough power would limit the entire rest of that string. So that's where optimizers can come in, and if you have any form of shading, you're highly likely to be recommending them. But even if not, you probably want to consider them, because solar panels are going to degrade at different levels, right? And as a result, you're probably not going to get the most out of all of them. Equally, what happens if one panel gets particularly dirty and you can't get it up to easily clean them? That's where optimizers can come in. Now, just to shake things up a little bit, inverters also come in different flavors. So you have what I'm going to call a standard inverter or a string inverter, depending on who you ask and where you look. But essentially, that is the inverter that is taking the power from your panels and turning it into usable AC power. Now, you can also get microinverters. They do the same job as a string inverter, but you can think of them as a mini inverter plus optimizer, which you attach to each panel. So rather than your optimizers, rather than your inverter producing, let's say, 4 kilowatts at its peak output, each panel would, let's say you've got those 300 watt panels, be able to produce up to, say, 280 watts. So you would then have each of those panels connected up, and that would give you your total amount. Different ways of doing it. Now, the microinverters are actually more expensive on the whole, but they do integrate the optimizer features, so it might be something you want to consider. And lastly, there are hybrid inverters. Now, hybrid inverters are for use with battery systems, and specifically ones that can also be charged by the grid. Now, a hybrid inverter will take the power from your solar panels, so DC power, turn it into AC power for your home. But if you have a battery installed, then they can also take AC power from the grid and turn that into DC power to charge your battery with. So essentially, you can cover yourself for both eventualities if you were to have a battery system. Now, batteries are something I'm going to talk about because I'm also having them installed, but I'm just going to leave them out at this stage. Hopefully that made sense. So how do you go about it? What is the process of purchasing a system if you're involved in it? Well, this is how I went about it. I measured roughly the size of my roof and, well, both sides, and I worked out the area I had available. This is important because solar panels come in very different flavors, and the higher the capacity, the likelihood, the larger the panel. As such, you're probably going to want to think about what kind of panels you want on your roof. You may want to consider the look, but you're really going to want to consider the size and therefore the total output. I live in a relatively standard UK terraced home, and I think the most panels I could get on is what I've got on each side, which is 10 of larger 400 watt panels. They're about 1.8 meters long and give or take around a meter wide. So that was the maximum amount that I could fit on my roof, and I really have maxed that out completely. If I had taken much smaller panels, perhaps I would have been able to fit quite a few more, but the total output is unlikely to have been higher. This being said, I might have been able to fit 500 watt panels on there, and they would have been slightly taller, but as I have that space height-wise, I probably would have been okay. But when you're choosing solar panels specifically, you're going to want to think about what you want and how much money you want to lay down up front. You could go with a relatively cheap panel by a, let's say, white branded or no-name manufacturer, and you know what? For the initial period, they'll probably do all right, but as they get older, they will produce less power. And some of the data sheets I read either weren't particularly believable, or the ones that were being honest really had steep drop-offs in the 85 to 80% range after 25 years. So that means after 20 years or 25 years, that panel will be producing 20%, sometimes more, less electricity than it did on day one. And for me, that's really not good because I'm hoping to stay in this home for quite a while, and I would like the system to perform long term. The other thing I considered when I was choosing solar panels was the failure rate of those panels. There are statistics all over the internet. Some people say that the failure rate of solar panels is as high as 0.4% for some manufacturers, and sometimes higher. To me, that's a failure rate that's kind of unacceptable and is a risk I'm not willing to really take on. So what I wanted was LG solar panels because their failure rate, I think I saw quoted online somewhere, is in the region of 0.00025% or roughly 1 in 800,000. Those are odds I'm more happy working with. Now, if you're following the solar industry quite closely, you might know that LG recently announced, well, beginning of this year, so not that recently, that they're going to stop producing, or rather now they have stopped producing solar panels. I still decided to go with those LG panels because they have committed to providing replacements for the next X years, which is good. but B, those panels are still much higher quality than many others on the market. There are some companies like REC that are producing similar quality panels, but for me personally, I wanted LG ones due to their reputation. In case you were wondering, LG said they had left the market as a result of the influx of cheap Chinese panels, which made it uneconomical for a premium panel manufacturer in the market. Bit of a shame if you ask me, because LG came up with some really interesting innovations. At the moment, we're also facing a supply chain shortage, so I didn't even get the exact panels I wanted. I wanted the LG 440 watt bifacial panels. Now, if you see bifacial on any panels that you're buying or you're potentially having installed, they're really interesting. Essentially, they're see-through partially, so the light can go through the panel, bounce off the surface behind it, such as your roof, and then the panel can absorb further light, so essentially up to 30% more output from the same panel size. So it's really good to get those if you can. Unfortunately, I haven't. I've got the 400 watts Neon H Plus V6 panels. Now, those came out at the end of last year, so right before they announced that they'd be stopping production, and they're interesting in themselves because they have guaranteed that after 25 years, that panel will be producing over 90% of its original capacity, which is mad. And it's a very linear degradation sort of curve. So I think it's about 0.3% a year is what those panels are going to lose. Again, to me, it's worth paying that premium for because you're paying a lot of money for someone to install it on your roof. So at the end of the day, you probably want the best equipment possible. So in terms of solar panels, I'd really do your research. I'd think about the panels you want, the size of your roof, and I'd really consider how long you think you're going to be in that home and whether you perhaps want to splash out a little bit more cash up front on that in order to secure higher rate in the future. Now, the other logic would be cheaper panels, or perhaps the cheapest panels, and in 10 years' time say to yourself, well, they're probably going to have much better tech around by then, and I'm going to replace it, or I'm going to move out. That's fine too. My opinion, and my way of looking at it, I'd rather have the higher quality panels at this stage. Now for the inverter, there was really only one way I wanted to go because I knew I wanted Solar Edge optimizers, so a Solar Edge inverter obviously made sense too. Solar Edge are a company that have been around for a very long time in the solar business, and it is what my parents had installed, and I really like the system. I like the monitoring on the app, and it just gives you that bit of peace of mind in terms of their warranty, and generally they've been really good to talk to and their support's been very good too. I did actually have a chat with their UK country manager ahead of recording this video, who very kindly gave some of her time to me to explain some of the things which I was trying to get my head around, which was great. So I wasn't influenced by them, but I did have that conversation. The reason I say I wasn't influenced is that by the time I got in touch with them, I'd already ordered all the bits that I wanted. So I'd made my decision independently, but then decided to get in touch with them, just so you know. Now, the inverter I've got is a SE6000H, and that's a 6,000 watt inverter. That means the peak amount of power it can produce is 6,000 watts. It won't always be producing that much because it's dependent on the panels, but that's something you want to keep in mind. Now, the panels I put up the 400 watt LG panels. I have 20 of them, so that gives you 8,000 watts of theoretical peak output. And this brings me to the first thing I want to explain to you, and that is oversizing your solar array to your inverter. Now, this is something that is an industry standard, and it's usually up to around 30%. You oversize your panels output to your inverter. So in this case, I'm actually around that number, and I'll explain why. Although, in theory, those panels can produce 8,000 watts of power, the fact of the matter is that for the majority of the time, your panels will be producing less than that because some of them will be in the shade. Perhaps it's a cloudy day. And really, only in the peak summer months are you ever going to have the sun sort of at that point, especially where I've got, a south-facing roof and a north-facing roof. The sun would have to be almost directly above to get that sort of efficiency. So I'm never really going to see 8,000. I may once or twice, but very rarely. So a 6 kilowatt inverter gives me the best chance of making use of those panels, because if you think about it, the bigger the inverter's output, the harder it is to sort of drive, essentially. The actual minimum amount of power to actually activate it is higher. So by having a larger array, you're actually making better use of that inverter. Also, and this is kind of trippy, and I've had to have it explained to me multiple times, but in many cases, a smaller inverter can produce more power than a larger inverter because that smaller inverter, it ramps up earlier in the morning, so it's producing more power faster in the morning, and it ramps down slower in the afternoon, so it produces more power longer into the afternoon. It's kind of hard to get your head around, but it has to do with the way, the amount of energy is required and so on, and the crux of the matter is that's probably where you want to listen to your installer. Now, I was rather adamant of having a 6 kilowatt inverter for a couple of reasons. The first is I would quite like to see some of those higher peak numbers in the summer, even if it is at a cost of less output during the rest of the year. But also, I would like to give myself some capability to add further panels in the future. So I actually worked out I could add another 5 panels to the current string of 8 kilowatts and still be within the limits of power that Solar Edge say for the optimizers and the inverter and the string size. So I could add some panels onto the flat roof I have, which, although very shaded, will still produce energy and not have to worry about potentially going above the recommended amount of watts, essentially, the amount of power that the string can take. So my thought process was 6 kilowatt inverter. That gives me a bit of room to grow the array. I could add a larger array, but I'd need at least 10 panels or 8 panels, I think, and I don't have enough space for that at the moment. So that's why you may want to consider a larger inverter. Now, off to my UK point. In the UK, if you want an inverter that can produce more than 3.68 kilowatts of electricity, you need a G99 application from your DNO, your distribution network operator. Now, that is not the company that provides your power. It is, well, that you buy your power from, rather. It is the company that runs the infrastructure that you get your power on. And in my case, that's UK Power Networks, but there's many of them all over the country. A G99 application, will take between 45 and 60 days, I think, with some companies. And it can cost a lot of money. Not the application itself, but they might say we need to upgrade a cable or you're too close to a transformer, and they may well deny your application as well. So do bear that in mind. The more people around you that have solar energy and the less people connected to your transformer, the less likely you are to get a higher amount of power production approved by your DNO. I've seen some ridiculous things, like £110,000 quote to upgrade your power. I think that was from one of the northern DNOs. So yeah, it's kind of crazy. My one, thankfully, had no issue of me producing 6 kilowatts. In fact, there's slightly higher than that because we also have permission for the Tesla battery, which was a further, I think, up to 5. But they had no issue of any of it. So you could be fine, but equally it might be a problem. It'll also delay everything. Now, if you don't, and you're happy with 3.68 kilowatts of output, which is quite a lot, right? If I just had my one roof of 4 kilowatts of panels, that would pretty much be, it'd be a bit almost undersized for the inverter, but it would work just fine. And, I wouldn't need to make that G99 application. I could use what is called a G98, which rather than an application is simply your installer informing the DNO that that has been installed and they have to say yes to it. Final caveat for the UK, if you wish to sell power to the grid, which if you've got a larger system than 3.68 kilowatts, you probably will, especially if you can't use all that power during the day, then you need to have your system installed by an MCS certified installer to get the MCS certificate that will allow you to use that system. Now that comes with a whole load of caveats. They control everything from the kind of roof mounts they use, okay? In my opinion, it's a bit of a racket, but anyhow, that's by the by. But you will need that if you want to sell back because your energy provider will want that documentation. Do bear that in mind. So, the last part of this, we've talked about inverters and we've talked about solar panels, is batteries. Now, I think batteries are really, really useful. That Tesla video, links above again, to me really encapsulates why it's so useful. Tesla is what I wanted. I wanted a PowerWall too, but currently the delivery time for one of those is Q1, Q2 next year. Some installers have them in stock already and have held stock for a while, and they're fine. Unfortunately, mine didn't, so I'd have had to order one. And yeah, Q1, Q2 next year is a very long time to wait, and who knows what might have changed by then. So I've decided I will go for an alternative. Now, this wasn't initially planned, but I realized that earlier in the year, Solar Edge had released at the time it was called the Energy Bank. It is now called the Home Battery, and I will refer to it as such going forward. They've released the Solar Edge Home Battery. Now, the Tesla PowerWall is 13.5 kilowatts of usable power, and the Home Battery by Solar Edge is 10, or 9.7 of that is usable. That is a bit different, but it comes with some interesting advantages at the moment. Also some disadvantages, but apparently some advantages. For one, it's a DC battery. Well, all batteries are DC, but it doesn't need to do any converting. So it takes the power directly from the inverter without converting it. So it's actually a more efficient system overall. Also, when I take the power out of it, it's using the inverter to do so. So it's kind of doing its job as if when it gives the power back to the inverter from the battery, it's essentially acting as if the solar panels were providing the power. It's very clever, and it means that the overall efficiency loop is much better, which is good. It means you lose less electricity during the whole process of sending it to the battery and taking it back out of the battery. And to me, it looks all right. It doesn't look quite as swish as the PowerWall, but that's okay. But it provides most of the features, I hope, that I want. Now, there are some caveats. Currently, it doesn't provide backup power. It was mentioned in the original press release, and I'm hopeful that Solar Edge addresses that with perhaps some new products at some point so that I can also have backup power here. Currently it doesn't, which is frustrating, but so be it. It's one of the things I love about the PowerWall. My parents have had various power cuts. They live in London, but small power cuts, and the PowerWall switches on pretty much instantaneously. You maybe have a cut for a second or two, and then you're up and running. It's a great system, and I want to have that in my house too. The Solar Edge system, though, does have an advantage in that it's quite a bit cheaper. It's quite a few £1,000s cheaper installed, which is great. And you can add up to 3 of them in total. So your maximum capacity of a single inverter would be 30 kilowatts. That's quite a lot of power to be storing at home. Now, the PowerWall can also be stacked, same kind of thing, but it becomes pretty cost prohibitive. At this stage, I have no idea how the Solar Edge Home Battery is going to perform, so make sure you subscribe so you don't miss any future batteries. Batteries? Any future reviews even. I have batteries on my mind quite clearly. So at this point, you have the basic information. Think about the kind of inverter you want. Think about the kind of panels you want. Think about whether you want to buy a cheaper inverter that maybe has a longer warranty and better efficiency. Do you want to go with more expensive panels or cheaper panels? And then have a look at some of the brands that are available. Think about the reputation they have a Google. It's really important, I think, to check out how other people are rating them, because it will give you an idea of longevity, whether there are any issues. You know, at the end of the day, you're dealing with a lot of high-powered devices that, you know, could in theory burst into flames. So personally, I'd want to choose something that I know is going to be safe, that I know is going to be efficient, and it's going to run for a long time without, you know, with minimal intervention on my part. Also, you might want to think about integration with other things like, you know, apps and so on, because it's great having, say, a battery and an inverter, etc. But if they can't talk to each other or you can't set them up easily, then what's the point? I think that you can be as conservative or not as you like when you're speccing a system, but my honest advice would be to put in as many panels and as much capacity and power output as you can. I doubt that our electricity use is going to go down over the next few years, especially if you're currently using gas and you're going to have to move to, say, an air source heat pump in the future, or you're thinking about buying an electric vehicle. All of these things are going to massively impact how much energy you require. So for me, having a higher amount of production than I need is only going to serve to potentially fill future gaps. And I suspect I'll need much more electricity than I currently produce in the future, but at least I'm giving myself a chance to produce quite a lot. There are other considerations. For instance, the strength of your roof will determine how many panels you can have. Perhaps if your roof isn't particularly strong, you might not be able to have as many as you want. Equally, the way your house is facing is important too. I mean, I'm going, as I said, slightly off-piste and putting north-facing solar panels on. It's unlikely that you're going to be recommended that, but check my future videos because we will see if it pays off. I think it will. But you might only have a certain amount of space on the south or the west or the east, etc. So look at all of that. Think about all of the variables that you have, and then think about the equipment that you want. And you know, I guess it's I was about to say the equivalent of buying like a BMW versus like a, I don't know, a Peugeot. But at the end of the day, that's probably not a fair comparison in terms of things like like repairability and warranty and so on. But you see my point. Hopefully you found this video useful. If you stuck with me to the end, well done. I realise there's a lot of information crammed into this, but I didn't really have any other way to give you this initial overview. The next video, I'm going to be talking about my install specifically. We're going to have a look at the panels that are up. We're going to have a look at the inverter, talk you through the battery. There'll also be a separate review on the battery coming up. May do one on the inverter as well. Definitely going to look at the panels. But then what we're going to have is a monthly, or at worst quarterly, update on how much power each side has produced, any sort of quirks of individual panels, any issues, how much of the battery we're using. Hopefully we can monitor that. I have no idea because there's no information, but we'll find out. But yeah, that's the plan. So thanks for sticking with me. If you have any questions or want to see anything specific or want to discuss anything specific, put it in the comment section because I will absolutely address them in future videos if I can. Make sure you subscribe and give the video a thumbs up because at almost 30 minutes long, I'm going to need all the help to get this seen by other people that I can get. Thank you for watching, and I'll see you in the next one. Goodbye.